Hi everyone, this is Kathy Vrentas, and I'm joining you via a recorded presentation today. I'm hoping to be available after my presentation to answer questions via Skype. For my 567 project, I developed a company called Lab Helper, which works in the laboratory supplies industry. Since I currently work as a scientist for the federal government, I've utilized my 12 years of experience in the life sciences laboratory setting, including experience in 6 different research labs, to inform my product design and development process this term. In order to come up with a business idea, I looked around my own laboratory to think about everyday issues that irked me. One such issue was the problem of carrying supplies around the lab or to other labs. For example, when I grow up bacteria cultures, every hour I need to go to take a reading of the cloudiness of the culture, which is on the other side of our building. Often I'll be carrying heavy breakable glass bottles, liquids, boxes full of plastic items with insecure lids, and biological samples. Sometimes I, as well as other scientists, will use a makeshift system like a cardboard box, or sometimes we'll just try to juggle everything. Using a cart can be unwieldy and slow. So, how can we carry these items safely but conveniently around and between labs? The Lab Helper provides a solution as a plastic-based, caddy-like carrying tool for the life scientist. Here's a design sketch to help you visualize the product, which is made of plastic that helps repel spills, which can also be captured and disposed of with an interchangeable, absorbent cellulose liner. The basic design features 4 compartments, and as we'll discuss in more detail later, the specific architecture of each of these units can be selected by the customer. Compartments can be selected to hold bottles, small reagents, samples at different temperatures, and common lab tools like the pipetter. Follow-on revenue streams will also be generated by the sale of special compartments and attachments. For example, we will offer a wheelchair attachment, and we'll also offer a cooling block module, which is made out of a proprietary licensed plastic which changes color when it warms up too much, as a warning to the scientist. Now, during the process of designing this product, I conducted a series of in-person, open-ended consumer interviews, and interviewees included lab technicians, graduate students, and postdoctoral scientists. From these interviews, I found that safety, spill and sample loss prevention, and convenience were the major drivers for needs and interest in a product in this category. The interviewees were unaware of any other major competing products that they used around the lab. Generally, the interviewees were using makeshift products to carry things, like cardboard boxes. However, the use of replacement products, like mini coolers, which come at a low cost, did play a role. When I conducted a perceptual mapping exercise across these 3 variables, convenience, spill prevention, and safety, most of the replacement products were perceived as being of lower quality than my product concept. However, you can see here that the mini cooler did score high on many of the variables, so I designed my product to offer significant sophistication in each of these variables in order to justify the price. My overall business plan for the company focuses around 4 major concepts. First, the use of the custom design of the product with interlocking modules that can be chosen by the customer at the time of ordering. Next, the opportunity to interact with a fun web interface when ordering the product. Third, a plan to generate follow-on revenue through the sales of associated accessories. And eventually, a plan to continue the business in the future by positioning ourselves as a producer of customized solutions for the life science laboratory, so we can maybe go into other products like other types of small, personalized labware. On the left here, you can see an example of what the web interface will look like upon ordering. Customers will have the option of taking a brief quiz to determine what their main laboratory needs are, and then the program will suggest modules they may want to order. The customers can drag and drop these on the main product frame to visualize what their product will look like before they order. We're capitalizing on the growing ability for customers to design their own iPads, t-shirts, and cell phones. Why not their laboratory equipment as well? Eventually, accessories offered will include nameplates and aesthetically based elements. And we even thought about having an iPad dock so that you could put your protocols on the iPad and it can connect to your device. So this method of online ordering and distribution will become a focal point of Lab Helper's marketing plan, and it will fit in well with our product's focus on fun and customization, paired seamlessly with safety and convenience. We'll combine this with a two-pronged approach for promotion, including the old standby of having tables at key trade shows and conferences in the scientific field. We'll also venture into YouTube-based marketing and contests for scientists, which is a tool that has become increasingly popular in the field, as evidenced by the efforts of companies like Life Technologies, which has used these to great success. We've set a price of $50 per unit, which includes shipping and handling, based on the results of customer interviews. Customers communicated that this price balanced a perception of quality with the affordability needed to order one for multiple members of the lab. Now clearly the target customers will be life science laboratorians, but I've defined the target market in more detail, with a focus on academic and government laboratories in North America to start, since this is where I have my largest network of connections for marketing. Each of these sub-markets shown here in the diagram on the left spends the bulk of their time at work in the laboratory, and they generally have significant control over purchases of low-cost laboratory items. Based on these constraints, and the National Science Foundation's Science and Engineering Indicators Report, I've estimated my target market at approximately 368,000 buying units each year. Now, as described before, our company doesn't currently have any major direct competitors, and we would start by competing against replacement items like boxes, carts, or the coolers. However, this is a difficult product to protect with IP, so I expect that copycat products would enter onto the market quickly through well-known sources like lab supply companies, including VWR and Thermo Fisher. So, how am I going to maintain my high sales numbers and a continuing competitive advantage? I plan to do this by grabbing market share with early entry to market, paired with my catchy marketing and ordering methodologies. Next, by developing a reputation for novelty, quality, and customization. And also by selling the follow-on products to the current customers as additional revenue. The product is relatively durable and does not need to be replaced frequently, so once we have a customer, they'll want to order supplies for our device since they've already purchased it. In addition to the competitive factors, I will also have to be cognizant about important external factors in the market environment, which I examined in a pest analysis. The effect of sequestration on the federal budget has already impacted laboratory supply spending budgets. One question is, will this have social impacts, such as the structure of workers in the laboratory, like the number of postdoctoral scientists? Also, increasing automation in the lab could reduce the market over time, although in at least the next 10 years, I foresee the market for my product to be relatively unaffected by this factor. Now, in order to move the product from my design sketches to the customer, I will be utilizing a contract manufacturing organization in the Midwest, which I'll call my CMO, to produce my products. I will also be utilizing their skills in the development stage to develop a plastics manufacturing process for each product module. At the CMO, the raw plastic materials will be turned into the different modules for my product on the assembly line using pre-generated molds. products will then be shipped to my combined office and warehouse in my current city of Des Moines, Iowa, by low-cost truck freight. My employees will assemble the modular components based on customer orders, which is a very quick process, and then they will arrange shipping by UPS pickup from my facility. Now finally, the key to the future success of Lab Helper will be dependent on the fiscal soundness of the business plan. So, I started off my financial analysis with an examination of the predicted incoming revenues based on my estimated market potential and size, as I was discussing previously. I am assuming an increasing awareness over a 5-year period, as well as a high trial percentage based on the results of my customer concept trials and interviews. I have also included in my launch calendar a strategy to send sample units to students and postdocs at key large research facilities at major universities, which will develop a buzz and familiarity with the product before the launch. On this slide, I've used the ATAR analysis method and a time frame that involves 11 months of development to develop a 5-year table of revenues. I do believe that these continuing sales figures are possible over the course of the 5 years without market saturation. First, since graduate student turnover is relatively high, and second, over the longer term, I do have some options to expand my markets. For example, I can expand into the non-North American market, which is a growing market in the life sciences, especially in Asia, to the for-profit companies, such as biotech employees, as well as laboratories in other science fields, like chemistry or environmental sciences. Now note that figures here, as well as on all subsequent slides, are provided in the millions. Next, I consider the expenses in each year. The use of my CMO structure helps to reduce the initial costs of startup, since I do not have to purchase significant capital equipment, with the exception of the molds that will be used for my plastics manufacture. Over the 5-year period, my costs will include hiring 2 employees to handle the logistics and customer relations, and I will pay myself a salary starting at the end of the first year. The web and initial development and computer-based design work will be handled on a contract basis. Shipping and warehouse space will be one major expense, as will things like marketing and the travel related to that. Estimation of manufacturing expenses was probably the most difficult part of making this table, and here I chose to go with a higher estimate per item in order to be prepared. So on the left here, we can see a graph of the cumulative profit, shown in purple. And based on this, my analysis predicts that my company will break even quickly. This is attractive for financing, but it also means I should be wary of the entry of competitors who might also expect to break even quickly. I've estimated that I'll need approximately $600,000 in startup funds, since in addition to my initial costs of about $250,000, I do need to finance the initial burst of CMO production to make sure we have enough of each module on hand in the warehouse as sales begin. Now over time, we should be able to trim the warehouse stock based on the history of the customer orders. To obtain this funding, I will consider a series of local Iowa-based venture capital associations, but I believe that my most likely option will be to obtain an SBA 7A, which is a startup loan, from a bank in the area. Now note that the analysis here has not considered the follow-on accessories, costs, and revenue. Once I break even and begin to accumulate a cash surplus in the second year, I will begin to produce the most important accessories as determined by customer survey. So, to conclude, overall, I believe that it would be worth going forward with my business plans for Lab Helper. This relatively simple product idea, if done well, can definitely serve a current market need and gap for life science laboratory and customers. The focus on the customizable product experience will be one element that sets us apart from others, and there is the potential for large returns relatively quickly if the sales forecasts hold due to the contracting of the manufacturing. The main concern I would have would be competition from copycat companies with a high ability to produce products cheaply by manufacture, and therefore I would need to focus on maintaining my competitive advantage, one element of which will likely be a continuation of the customization theme, with follow-on sources of revenue, including very novel and innovative accessories, and whole new income streams from related lab products in the future. Thank you very much for listening to my presentation today, and I'll open the floor for questions.